much as $1 to $2 trillion, comparable to 20 Hurricane Katrinas. A super CME struck the Earth 150 years ago, but scientists disagree on when the next one could come.
The likelihood of that happening in our lifetime is probably not that good, but we just don't know. We don't have enough data.
The most powerful coronal mass ejections that could cause widespread damage over all of Earth probably occur only about once every millennium or so. Nevertheless, having a huge calamity every few thousand years is really a big deal.
Our best protection may be in the artificial eclipses aboard spacecraft monitoring the sun for CMEs. If improved warning systems are put into place, we may have enough time to shut down the electric grid to prevent it from burning out, dodging the deadly bullet otherwise aimed straight for us. A coronal mass ejection may be the most spectacular phenomenon uncovered by eclipse science. But the universe is full of other eclipses, each one teaching us something else about the cosmos. Even a short hop into space, no farther than the moon, turns the tables on us as the Earth becomes the celestial body to eclipse the sun.
Think about how important that Apollo 12 image was, where they turned the camera back towards the Earth and you could see the Earth eclipsing the sun. Those images from Apollo were really epoch-making for humanity. It gave us our first real sense of the Earth as being an object floating in space.
Farther out, the Cassini space probe looks at Saturn, virtually black, surrounded by backlit rings as it blocks out the disk of the sun nearly 1 billion miles away. A very different view of our own moon eclipsing the sun comes from the Stereo B spacecraft. From deep space, the moon appears much smaller, and it crosses the sun's disk in what's called a transit. This kind of eclipse may be pivotal in answering our questions about who else may be out there in the universe.
What makes transits so important is it's one of our ways of actually discovering what are called extrasolar planets, planets orbiting other stars.
The tantalizing possibility is tempered by the daunting problem of actually making it work. Finding a planet transiting in front of its star is like seeing a flea crawling across an auto's headlight. But science is rising to the challenge, and new space telescopes trained on the tiny eclipses that uncover planets around distant stars are about to strike gold. After centuries of wondering, the discovery of another Earth in the depths of space is suddenly within reach. If the search for eclipses starts with the most spectacular examples here on Earth, turning our view out into space reveals other eclipses, not only in the solar system, but far beyond, where they're key to one of astronomy's hottest pursuits, the hunt for extrasolar planets.
A very important kind of eclipse right now is the eclipse that occurs when an extrasolar planet, a planet orbiting another star, passes in front of the parent star. It takes a very sensitive telescope to detect that slight dimming. The most famous telescope project right now is the Kepler Space Telescope that is out there in space looking at over 100,000 sun-like stars and watching over a period of years for the transits of actually Earth-like, Earth-sized planets going in front of those stars.
It'd be great if we could find planets orbiting other stars by simply pointing a telescope up into the sky and taking a picture of one. But that's really tough. One of the reasons that that's really tough is because the stars are about 10 million to 10 billion times brighter than the planets that orbit them. And I can demonstrate that really easily with this searchlight. When I turn it on, you see that I become completely lost in the glare of this light, just as a planet is lost in the glare of the star that it orbits.